Fantastic. Welcome. So my name is Mitun Zavery. Let me share my screen and then we can kind of get this going. Share my entire screen, so bear with me. Fantastic. All right. Welcome everyone. So again, my name is Mitun Zavery. I'm actually the director of the solution engineering team here in Sonotide. Today's topic really, and this is not sort of new by any means, right? But really, it's a topic about understanding what the role of the developer is in 2021. And you'll notice I've highlighted the developers, right? Because actually, developers are now playing a larger role within the entire development lifecycle for an organization, all the way from the initial code commit all the way down to obviously, the infrastructure as code itself as well. And so today, really, it's about describing the problem, understanding where that role is going to change or affect the jobs of the developers really as well. So let's go back in time a little bit, right? Everyone knows that attack vectors have become pretty much more prominent these days, right? There have been various different notifications, publications out there, blogs that have talked about establishments being attacked. So everyone has probably heard of the dependency confusion attacks. Everyone has probably heard about the namespace attacks. Everyone has probably heard about CodeCov recently as well. So this is becoming a real problem for enterprise organizations as a whole. And of course, this has been happening, like I said, this is not relatively new. This has been happening since 2000. The challenge, though, is that most organizations that don't innovate and don't change the way they behave and function are prone to being replaced, right? So 52% of the Fortune 500s, globally in the world, have effectively been replaced and are non-existent anymore because they didn't adapt to change, right? And everyone has seen the story about Blockbuster, right? Just as an example, Netflix has taken the crown there because of that. Now, that was all down to how quickly organizations innovated. So that hyper-competitive sort of market has really forced organizations to digitally transform. And again, digital transformation, this is not a new topic, right? And this has existed out there in the wild for many years. Digital transformation in the 1990s meant something completely different to what it meant in the 2000s, and completely different to what it means now, in 2021. And in fact, actually, it's taken a entirely new crown altogether, especially during this time that we've had over the past 2 years. So to remain competitive and increase revenue and create new markets, we've really had to adopt a completely new way of working, deploying applications, delivering features and capability to our consumers, to our market. And I think about, obviously, digital transformation as a means for developers to take more of sort of an impact of change, right? And we all know kind of software has really changed that approach, right? But what was identified when we sort of sometime did the state of the software supply chain, sort of 2020 last year, we extracted quite a few key, what I would say, metrics from those. These are things such as 90% of all applications that are developed in the industry are based on open source. Now, little did anyone know that, in the 1990s, when people were just creating sort of C projects and creating snippets of code, that would become a way of sharing code and sharing problems, throughout the industry. And so the open source ecosystem has become a really widely used concept, right, within all organizations. But not a lot of organizations have really grasped the idea that open source is used throughout the organization and how much open source is used, that is the challenge that most organizations face, right? So just based on our survey, we identified that actually 1.5 trillion OSS download requests were expected in 2020. And obviously, we're going to run our own software supply chain report later on this year. But again, we're expecting this to be much larger, especially given the change in sort of the environment and the culture of working at the moment. So this 1.5 trillion is probably going to be closer to 2 or 2.5 trillion, right? And every single day, developers and organizations are creating new open source projects or new open source artifacts that are being deployed out into the open source community for other organizations to come back and pick up. And yeah, I look at this as a great way of contributing to, you know, the wider sort of digital transformation, right? In terms of the world, how we sort of work and how we change and behave as part of that. But just the fact that nearly 21,500 new software binaries releases per day. Now take that across the month and take that across the year. This is an awful lot of change. If this was in an organization and we had this many releases a day, right, like the days of Etsy, it's just so difficult to manage. And so developers now are playing an even more pivotal role inside of managing this change, right? Open source developers are deploying so fast that organizational developers, people as part of enterprises, are having to cope with that change. How do we find the right artifact to use? How do we make sure that that thing that we are using is valid for my organization, my enterprise? And so with all things open source related, there's a age-old analogy around it aging like milk, not wine. And this brings into focus really, and this statement still holds true today and has been a statement that has existed probably for about sort of 6 or 7 years. More and more open source being released is great. However, it really brings focus on the open source community as a whole being vulnerable to potential attack vectors. And we've seen that obviously with CodeCov and SolarWinds and so on. Now, we did obviously a survey on this, and we identified actually that 1 in 4 of the organizations that we've surveyed actually experienced a breach. So not just we've identified a problem, but actually identified a potential open source breach in their organization in the last 12 months. Now, a breach doesn't just mean exfiltration of sensitive information, right? A breach could be hijacking of the infrastructure or malicious intent, right? But with all of the sort of GDPR rules that exist now, especially here, sort of within Europe, this fact here itself opens up the industry and the organizations to huge fines, right? British Airways recently, several other banks obviously have been impacted by that as well. And so the focus on just hygiene, quality of the open source components has become extremely critical. And so we sort of see that this growth in terms of the quality of the components coming across is really sort of is increasing, right? So every year there's actually 430% year-on-year growth in cyber attacks, and now these individuals are targeting open source projects because guess what? As part of your software supply chain, that's really the easiest entry point, right? The open source projects. Now, this is not to say open source projects are bad. Actually, in fact, they're great, right? You don't want to have to reinvent the wheel. But that is, at this moment in time, one of the weak links inside of your software supply chain. And actually, when you go and look at the open source components out there in the world, 1 in 10 of these open source downloads, right, have known vulnerabilities. Just the fact that they have a known vulnerability doesn't necessarily make them vulnerable, right? Depending on the use and how you're actually consuming that component. But 1 in 10 open source components have known vulnerabilities. Now, if we go and look back at the previous slide, the statistic that 24,500 new releases, that basically means at least 10% of them are vulnerable. So 2,500 of those components, if you happen to download them, will be vulnerable. And so organizations have to start to focus on thinking about, how do I manage the open source aspect, or how do I govern the use of open source across my entire software development lifecycle? And really, to kind of put it into perspective, what we've done is we've created almost a timeline. And credit goes to, obviously, Ak Sharma here, who's created this, who's one of our security researchers, and has created this timeline that pretty much describes the breaches as they happen. And you can actually see, if you follow along, and look at the different use cases that we have here, the evolution of the type of attacks that are actually happening in the open source community. From the days of when everyone talked about Heartbleed, right? At that time in 2012, the OpenSSL breach, Heartbleed, caused huge problems, especially with some organizations, right, in the US, right? One of the Presbyterian Church, obviously, there was an issue there where it could be linked to potential deaths, for example, right? Here, 4 years later, when you think about it, right, in the form of this evolution, you then have things like the Backstabbers collection, for example, right? 216 typo squatted malicious code injections themselves in the open source projects themselves. So that's been happening for nearly 4 years, sort of under the radar, without anyone sort of considering that these are potential threats. Of course, everyone heard about Equifax, right? With the fact that a breach was exposed within 3 days of that open source, that vulnerability attack vector in the Struts open source project being known. 3 days, right? And so that's now become the talking point really in the industry around how quickly are people able to breach your environment. Well, if we look at the top row and you say, from 1 year's time, we've been noticing this malicious package injection and people attacking the open source community. In fact, that 3 days now is irrelevant. The minute an open source project is made vulnerable and a potential open source contributor happens to be malicious, it's not 3 days anymore. That is a 0-day vulnerability. That thing, as minute it is consumed inside of your organization, makes you vulnerable to the potential risk of using open source and the risk of exfiltration of sensitive data, credit card information, insurance data, personal addresses for individuals, whatever it may be. Even private keys, for example, that obviously was exfiltrated through the CodeColv vulnerability that happened really recently as well. So you can see that even though it's been happening, the focus on the open source community and the ability to manage that governance has not really been taken seriously until now, when it is becoming more and more obvious that these attackers are going after the open source projects themselves and hijacking the open source projects as well. Exactly like Alex Burson demonstrated, where he sort of managed to hack into fairly large profile organizations, 35 of them to be to state out exactly, where he was able to exfiltrate information and actually hack into organizations like Apple, Microsoft, and other companies as well. So this really here is just to kind of set out that these are real issues that are happening today in the wider open source community. And you're probably thinking to yourself, well, do I even use open source? Well, the truth is your developers probably do use open source, right? And so that role of that developer now is becoming more and more relevant. If you want to obviously know a little bit more about the CodeColv, please visit that URL at the bottom there. That is obviously the most recent one that is still evolving. It happened a couple of weeks ago, but it went undetected for 2 months. And effectively, most developers understand and know what code cov is, right? And someone was able to execute arbitrary commands on the servers by using the code cov utility itself. So why are we here today, right? As software engineers, why are we building software, right? And what's the reason for building this software, right? If you think about it, software has kind of consumed the world, and we are focused on building better software. But why? So to understand really the answer to that question, you have to think about how did we evolve from being completely industrialized to focusing on software. And there's a gentleman called Edward Deming. And this is a quote from Out of the Crisis, one of the books that he focused on. Create constancy of purpose and dedication to improve a competitive position, to keep the company alive, and to provide jobs for their employees. So employees, right? Everyone classifies themselves as an individual within an organization that works for them. But what did employees mean back in the 1980s versus what do employees mean now, right? And I highlight this because this is a really, really important fact, right? What does employees mean? How many employees do you have in your organization? And how many of those employees focus on a specific role inside of that? And if anyone doesn't know, obviously, who Edward Deming is, he obviously implemented, Toyota's approach to the supply chain, right? So this is where the concept of the supply chain came, and about sourcing better parts, reducing waste within your production manufacturing process. And these processes today have really defined what the software supply chain is, right? And his learnings from the lean approach in Toyota's, making Toyota and also Ford become some of the largest, most successful automotive organizations in the world, have trickled down into software today. And what they've allowed organizations to do is to build software faster, right? And deliver capability faster. But if you look at automotives, they obviously used to, at some point, design parts and physical parts to go into vehicles. So product lifecycle management, if you want to call that. And that's a process of a very, very long length of sort of research, implementation, testing, and so on. But software now is kind of similar, but the feedback loops are much faster, right? So of course, software has kind of driven this innovation and this digital transformation. And of course, that's what has driven organizations to be better, digital transformation. But again, the question, how have we been able to, as a society, really transform our approach into digital transformation and delivering those capabilities and delivering those features faster out to market? It's because developers are getting faster. The developers themselves are innovating. They are the ones creating new capabilities, new features, whether it's within organizations or within the open source community. They are the ones that are driving that innovation and driving the pace at which we innovate. So one thing that is very clear to us, right, in the industry is developers are our allies, right? Creating that community of open source developers and the developers inside of there will make us more successful. It will allow organizations to innovate and move faster into new areas and new products. And that is simply because developers have realized that there is no point in reinventing the wheel. If I know someone has created something that is functionally perfect and works, why do I have to go and create that thing all over again? It doesn't make sense. And so they are using open source projects. And whether that is open source within your own organization or open source from the wider community, it's still reused open source. And so, we come to the point of we know it's not a secret that developers use open source, right? But we also know that not every single developer has the intent to create open source components equally and of good quality. And so, yes, we have all these things that are coming into the open source community, and there are, huge amounts of downloads, and many, many people are creating new open source projects. But the challenge that still exists is the 3 points here. Are they created equally? Has it become more complex by using these open source ecosystems? And how do I know if an open source component that I'm using has any other dependencies on it that are, again, good quality or complex? We don't. And so you need the ability to provide this information to the developers, because the developers focus on very much what they are using, right? So they're direct dependencies that they are using. And I love this meme actually, because most modern day infrastructure is probably being held up, and it's a very complex modern day infrastructure, especially with Kubernetes and containers and pods all running now and delivering our services like banking applications, retail, etc. But actually, all of that is probably being maintained by some poor person in Nebraska or in the Antarctic, and has been maintaining that single project since 2003 that everyone around the globe is using. And it's that one weakest link. And if I take that one weak link away, you've now got a serious problem in your modern day infrastructure. But guess what? That one project is allowing us to build this entire complex infrastructure above it. And it's allowing developers to deliver value faster. So I come to, the State of the DevOps report, actually, that was done in 2020 as well. And one key thing that I took away from the State of DevOps 2020 was this concept of, the DevOps evolution model. And unfortunately, DevOps evolution models, are just that. It kind of says what you must get to be at a specific stage. It doesn't really tell you how to get to that stage. But these were the two paragraphs that summarized exactly what the entire DevOps, State of DevOps 2020 report came down to. Security integration, right? So ensuring that organizations deliver security into that process and remediate critical vulnerabilities very, very quickly, but also provide a self-service approach. That makes sense, right? If you think about it. Empower the developers, give them the tools that they require to fix the problem. So shift left, provide that in their IDs, build it into the build process, the pipeline, build it into your checks, right? So if you're doing develop, build, test, UAT, prod, whichever process you're using, build that into that workflow that you have. And the DevOps evolution model, of course, talks about the different stages that you must go through. And if you spend just a couple of seconds kind of looking at this and saying, well, really, what does this mean? What personas really are going to be able to help me get to stage 2, which is the standardization stage, or get to the self-service stage, which is I want to do automated remediation. I want incident responses to happen automatically. I want the security team to be involved. How do I get to managing my software supply chain completely? Well, if you've spent that time to kind of look at it, you'll sort of realize very quickly that actually the developers play a huge part across the entire DevOps evolution model. They have really become now the people that are the champions of making change. They can certainly influence everything you do in the entire organization. And so you will see developers at stage 1, at stage 2, at stage 3, right, all the way down to stage 5, with the security teams, right, with the operations teams, to really understand how to mature that security governance as part of the organization. But when you talk about DevSecOps or DevOps or SecDevOps, depending on where you're from, that really talks about 4 key parts, right? The DevSec, legal, and the ops part, right? No one has really coined the word DevSec, legal, ops yet, right? But the point is it's DevOps. It's everything between the development and the operations, right? And manual governance processes just simply don't scale. And we know that. We've been trying to automate the entire process for many, many years now. And so trying to manually identify a problem in your development pipeline and getting a developer to fix it just simply doesn't fit well with the development team, right? And then not having visibility into what the organization is doing in the ops side of the world, and not understanding what you've just deployed out to your production environment is, again, an extremely risky strategy. So we know manual governance doesn't work. Having these single points of control simply don't allow us to move fluidly through that pipeline. And so everyone is striving to, of course, build automation into that. And really that basically means building some resemblance of structure around the automated pipeline, so that you have a way to either enforce the policies that you are mandating on your developers, or educate them, empower them to make that decision themselves, right? Policy as code, for example, or giving them the tools to say, this is how you fix the problem, and this is now integrated into your pipeline, so that you don't have to understand the security policies or the rules or the regulations. It's inherently part of your development process, and these are things that you have the ability to influence. Now, when I look at digital transformation, and I was trying to sort of think about it, well, what does this mean? We sort of broke it up into two aspects, right? You want to increase the competitiveness and produce higher quality applications, but you also want to increase the revenue, right, of your organization by delivering these products faster. And really, this is about kind of the value stream, right? What are you doing that is then going to impact the business, right? What does this feature really help us improve the product release cycle, or allow us to earn more revenue as an organization? So these are the two key things when you look at digital transformation, organizations are trying to achieve. And they usually filter down to what are they going to affect from a security standpoint or a DevSecOps standpoint, right? This lens is focused purely on the security part of it, right? But if you think of DevSecOps as being overlaying as part of those two initiatives for digital transformation, then you need to replace inefficient processes that are inside of your organization. And you have to do that using automation by some point. But the only way you can automate this is by having the ability to apply policies, customized policies. So a full spectrum view of open source governance. And so this allows you as an organization to push those policies down to the developers so that they understand what is required. And so if I now break that down into the DevOps view of the world, this is really what organizations are achieving, right? They are achieving the ability to reduce the amount of time developers are spending looking for components in the first place. If I tell a developer that something is wrong with their code and it's because of a specific component, then inherently what I've done is I've stopped the developer from working, and I've asked them to go and find a component that better suits the policies of the organization. That takes time. And of course, time means the developer is no longer working on their backlog or that feature or that capability that they needed to get out tomorrow evening. If you look at it from an application security perspective, right, we want to reduce the probability of security breach. So we want to push out these new capabilities and these new features, but I just simply don't have the time to define individually or review individually all of my releases, especially in the world we are in at the moment where you are simply deploying as part of your pipeline. How do you validate that manually? You can't. It should not be a retrospective activity either, because what you've done is release something into production and are retrospectively checking it. That doesn't happen in the world, right? And no bank would allow that to happen either. So there you have control gates and quality gates in the way to stop that. So you have to build this automation into it. Now, I'm only going to focus on really two parts, the application development piece and the security piece. But if we're able to reduce the developer's time by sort of 4 to 8 hours for development because of the use of open source components, then really what we're doing is we're saving the developer 4 to 8 hours of actual work. They can then focus their attention on creating better features and better capabilities. Okay? And if we can reduce that time that a developer spends trying to find the right open source component, well, what component do I use, right? If I know it's version X and we're saying that version X doesn't work, but that thing looks like a wheel and he or she wants to use the wheel, but there's a vulnerability with it. What are we doing to help the developer to find the right version of the wheel that doesn't have a vulnerability or doesn't have a fault? So all of these aspects that we think of when we think about digital transformation all affect the developer. And the developer now is starting to wear multiple hats. And everyone talks about shift left and putting more onus of doing this inside of the developer pipeline. This is becoming very difficult for the developers because there are so many hats that the developer needs to wear. And this is a big, big burden to put on them, right? So we need to find a way to do this cleverly, right? And so we also want to eliminate the bottleneck really that security plays sometimes, right? Which is reviewing the applications, right? And they spend hundreds of hours. And we have a concept actually within the industry where there are probably 100 developers to one security individual and probably 10 ops people in the middle of that. That's a lot of code changes to review for every single security person. And you'll find actually in most organizations, it's 100 to 1, the security to developers, right? So there's just simply not enough security research or security people in an organization to validate the components that are going out. So let me take you very simply through a bit of a journey, right? Let's see what this means. So my developer will want to use components. Now, wouldn't it be great if we could just simply block the bad components coming down? Now, my developer's not done any development work to this point, at this point anyway, they may have done something before, but they've not had to do any development using a specific component and then it be rejected further down the pipeline. But wouldn't it be great if we could provide that developer with, even if that component has some, let's call them policy violations, but provide them with early feedback into what is the thing that they need to fix so that they can use this component? Wouldn't that save them time? Of course it would, right? Would it be good if we could provide the developer with a trusted known source? The ability to say, if you gather your components from this system, for example, then yes, we're going to provide you with those trusted components and they're going to filter down into my organization so that I can control the quality of my application. Now, from a legal persona or a security persona, I know that most commits are going to trigger a build pipeline. That is a great opportunity to validate the code. You already do that with code quality assessments, SaaS assessments. But wouldn't it be great if we could look for open source components as part of that as well, which typical tools like SAST and open source code quality don't, right? They look at the attack vectors. It'd be great. Now my security team and my legal team have created some automatic feedback loops. And so I can feed back to the developers much earlier, right, in the pipeline, that a potential change that they've made is going to impact the product as a whole later on. Wouldn't it be great as part of my testing phase, I can start to really enforce these policies and say, well, we need to fix this problem. This can't be just put as a waiver and a backlog and someone can go and fix it at a later date. This simply cannot be pushed out, right? That's an automated feedback loop. And now my security team and the developer are all on the same page because they understand what the policies are. They understand what needs to be validated and verified before I'm going to push this product out into a production environment that my end consumers are going to use. And that's fantastic because now we're all on the same page and we've enabled the developers, and the developers understand the aspects of compliance, legal, security, operational issues and configuration issues, because they're the ones that have the ability to change this. Now, that's fine, but what happens when a 0 day comes along? How do you monitor that? So being able to control and monitor those things really help an organization, protect their estate. So you have to secure the pipeline. But if you haven't already figured out, every single one of these control planes feed back into the developer. So the developer's role is really becoming more and more critical and important in this entire software development lifecycle. They need to be empowered, and the tools need to be provided to them to make those decisions in an automated way. We cannot just expect the developers to make those decisions. We have to help them and provide that for them, because really their focus is about creating new capability and new features. So at a high level, this is really, if we were to take that and transpose that onto an architecture diagram for the organizations that you work for, you'd probably end up with something very, very complicated like this. But the real story here is the adversary right at the top, right? What is that adversary doing? What are they trying to attack as part of your product? And your product is wide stretching like this. And every number on here is effectively an automated feedback loop feeding back into the developers. These are all stages where the developer can get feedback to say, something doesn't seem right, we need to fix it. So rather than sort of kind of describe and talk this, I thought, let me show you actually. So as a developer, if I'm developing a project, I want to know what that risk is. And so as part of my development, I have the ability to see if there is a potential policy violation or an issue from a security perspective with a particular version of code I'm using. So this is a purposefully vulnerable struts application. And you can see here, these are all of the components that we've detected as vulnerable. All the light gray ones are obviously focused on the transitive dependencies. I, as a developer, don't have control over these. So maybe what I can do is I can focus on really the things that I can make a change on. So actually, I know I can make a change on iText PDF, for example. There might be a licensing issue, or there might be a vulnerability associated to that. And so I can see straight away that this version of the thing that I'm using has these violations. But what does that really mean? If I click on View Details, I actually have the ability to see, do you know what? There's actually a banned license associated to this component. So maybe I need to go and speak to my legal team or speak to someone that says, is this really a component that we should not be using? Or is there a better version of the component that I should be working with? Let's talk about security, right? Let's look at Commons HTTP client. It's a typical component that typically has some vulnerabilities associated to it. So here's one, right? It's Commons HTTP. There are some issues. There are 9. There are 5 policies, but 9 being the highest. Let's take a look at that. What does that show us? Right. My organization has vulnerabilities or policies that define this particular issue is not acceptable for my organization. So I need to go and think about, what does that mean as a developer? What does a severity 7.5 mean, right? How do I go and resolve that? What is the threat? And here we go. There is a denial of service attack on that particular issue. So as a developer, I'm now empowered and I now have the ability to go and make an informed decision about an issue that potentially will get rejected during the build pipeline or during the deployment phase. I'm not wasting my time triggering a build. I can fix the issue right here. So I get immediate remediation information right there. So that's really powerful for me. But as a developer, I, of course, want to see the full impact of a scan, right? I want to know what are the things that are included as part of my information, part of my scan. So I want to see what components actually are included in my final artifact. And so I can then associate that back to a commit, and I can see which components are there. Now, if I look at the components, because I want to focus on the thing that I control, which is the component, I can actually go into here and say, well, here is a particular component. I can see that actually this is a third-party dependency that I've brought in via another dependency. And actually that was brought in by the Spring framework that I have over here. So this version of Commons Collection was brought in by some other version of my Spring security framework. But in reality, if I want to take ownership of this component, then I should be using version 3.2.2. But actually, I'm not just going to assume that this is correct. I want to look at the vulnerability and I want to see actually what the problem is. And so I can go and look at that and I can see all the remediation information related to that and the recommendation. This is my guidance. This is what I need to do to make sure that I fix the problem, even if I want to use that version of the code. But most importantly, I know what version ranges are affected. So I can make an informed decision to say, do I use that or do I not use that component that's inside of there? But what developers typically are doing these days is they want this as part of their workflow. They want this as part of the thing that they are using. And so if we say that the code commits, the pull requests really are the things that we are using, right, as developers, then I want to see this inside of my code, my PR. I want the recommendation to be in my PR. So I can actually have things like merge requests or pull requests that are created so that I'm told what the fix should be. So as a developer, I'm now really empowered to actually make this change. And so this complex diagram, this complex architecture now becomes a lot simpler for the developer to sort of understand and use. And really that's what we call sort of the full spectrum software supply chain management, right? And it talks about 4 aspects: first-party code, third-party code, infrastructure code, and containerized code. These are all things that are impacted by the developers and should be taken into consideration when developing software. So there's a great quote that I like, right? So obviously, Mike Stank, who's VP of Platform for Circle CI, stated that there are four things: availability, cost, security, and developer productivity. If you're able to have the security aspect as part of the developers and empower them to know what those security policies are, you really increase developer productivity because they now have the ability to simply go and execute on what they need to focus on, right? They're not having to divert their attention, move to something else, okay? They have the ability to do that. And there's a great saying that I've come across by Brian Fox, actually. The arc of software innovation is long, but it bends towards empowered developers. You empower your developers, you really allow the organization to flourish and thrive and innovate in the market that is now becoming highly competitive. And in the world that we're in right now, digital transformation and highly competitive markets are just a common thing, right? What is great today, tomorrow will be something that is of the past, right? And so we have to change and innovate with that time. So Thank you very much, everyone, for listening. I hope you found that really informative. I'm going to be around for questions. I'm available for questions now as well, if anyone does have anything. But I hope you found that useful. Please reach me out. I'll be in the Slack channel later on as well. So if there's anything you have or any questions you have, please reach out to me. If anyone has any questions, please drop me in the Q&A. So yeah, I'll be here for the next 20 seconds. And if not, I will end the session. Fantastic. Okay, thank you very much.